Let function f is such that x2r be a real valued function, right? Now we say that x0 is said to be a maximum point for the function f if fx0 is greater than or equals to f of x, right? If x0 is said to be maximum point for the function if fx0 is greater than or equals to f of x for all x is in x. Now fx0 is said to be maximum value of f if minimum value of function if fx0 is less than or equals to f of x, right? Now what is the sufficient condition for the maxima minima? The sufficient condition is that function is to be continuous function and the subset S is the subset of R which is bounded and closed subset of R, right? That is the domain is closed and bounded. This is a sufficient condition but not a necessary condition, right? It is sufficient condition, not a necessary. What does the mean that? That is, it is if the function is not continuous, then this does not imply that the function has no maximum, no minimum, because if the function is not continuous, otherwise that's why it has a function has a maximum and minimum also. What is the sufficient condition? That f is such that closed interval -1, 1 to r defined by function fx is equals to -1 at x equals to 0, x is not equals to 0 mod of x, then the function is not continuous at x equals to 0. Function is not continuous at x equals to 0 because if you take 0 then it is -1 and it is not equals to 0 then it mod of x. However, fx has minimum at x not equals to 0 and maximum at x equals to -1 and 1. That is the graph of the function which is not continuous at 0 but it has maximum and minimum, right? Now second the function is f is such that -1, 1 to r -2 and +2, x is less than 0 then -2, x is greater than or equals to 0 then it is 2. It is not a continuous function and not a closed and bounded subset of r, right? That's why it has not maximum minimum, but it has maximum value at 2 and it has maximum minimum value at -2, while both conditions are violated, right? Now f is such that closed interval -1, 1 fx equals to x square. This is a continuous function and closed and bounded interval, and it has maximum and minimum both exist. So this satisfies the condition given.